Today we will learn about chance and probability. Suppose you are playing a game of snakes and ladder with your friend. You have to walk only 3 places to win, and it is your turn to throw the dice. If you throw the dice, will you get the number 3? Think. You cannot say with certainty whether you will get the number 3 or not. But there is a possibility or chance of getting 3. Can you tell me what is the chance of getting 3 in this situation? Think. Let me tell you. Throwing the dice is an experiment which can have outcome 1, 2, 3, 4, 5 or 6. We say that in the experiment of throwing a dice, the total number of outcomes is 6, since we are required to get 3. Therefore, the number of desired results, that is, the number of favorable outcomes is 1. In this way, we can say that the number of favorable outcomes is 1 out of all 6 outcomes. This is why we say that the probability of getting a favorable outcome is 1 out of 6, that is 1 by 6. To know the probability better, let's understand some of the terms used in its context. An experiment in which more than one result is possible and the result cannot be accurately predicted is called a random experiment. Can you give any example of a random experiment? Think. Let me tell you, tossing a coin, getting a candy from the candy box without looking into it, etc. are all the random experiment. Can you tell me if the experiments like to taste the sweets and find if it is sweet or not, to drop the stone from a certain height and see if it hits the ground or not, are also random experiment? Think. Sweets will always be sweet. Similarly, if anything falls from some height, it definitely comes to the ground. That means, in such situation, we know in advance the result of such experiments. Therefore, we cannot call them random experiments. Now think, if we toss a coin, whether the chance of getting a head will be greater or the chance of getting a tail will be greater. Think. On tossing a coin, the chance of getting a head is equal to the chance of getting a tail. We say that the outcomes are equally likely. Now imagine if we write numbers 1, 2, 3, 4, 5 and 6 on the faces of a matchbox and toss the matchbox. Will the probability of getting each number in this case be equal? Think. You are right. Since the size of faces of the matchbox are different, the probability of getting each digit will also be different. Therefore, here the outcomes cannot be equally likely. Each outcome of an experiment or a collection of outcomes make an event. For example, when we rotate a dice, then in this random experiment, getting one of the outcomes from 1, 2, 3, 4, 5 or 6 is an event. Similarly, getting a number which is greater than 3 or getting an even number is also an event. Let's talk about the event of getting a number greater than 3. Here, favorable outcomes are 4, 5 and 6. In this way, there are 3 results of the occurrence for the event of getting number greater than 3. But any number 1, 2, 3, 4, 5 or 6 can come up in this experiment. So, here the total outcomes are 6. For the event of getting number greater than 3, the probability of an event is the ratio of the number of favorable outcomes of the event to the total number of outcomes in the experiment. Here, the probability of getting a number greater than 3 will be 3 by 6 is equal to 1 by 2. If the event is certain, for example, getting any number from 1 to 6 on the dice, then the probability is 1. And if the event is impossible, like getting the number 7 on the dice, then the probability is 0. But when an event is likely to occur, such as obtaining a number greater than 3, then the probability is greater than 0 but less than 1. In this way, the probability of any event can be 0 or more than it, but 1 or less than it. Now, let's look at some situations related to use of chance and probability in real life. During elections, people are asked about their choice. The number of answers received is used to find the probability of winning of each candidate, and exit polls are obtained based on it. Suppose your elder brother has got 85% marks in a government examination. If last time 1,800 students have been selected out of 2,000 candidates who have secured 85% marks, then we can say that the probability of selection of your brother is 1,800 divided by 2,000, that is 9 out of 10. Now, you can find out more such situations by yourself. Today we have learned about chance and probability. In the next video, we will see some interesting examples related to them. Today we will see some interesting examples related to chance and probability. There are some paper slips in a box on which numbers from 11 to 17 are written. If a slip is taken out of the box without looking at it, what will be the probability of getting an even number on the slip? There are a total of 7 slips in the box on which one of the numbers from 11, 12, 13, 14, 15, 16 or 17 have been written. So, if one slip is taken out of the box without looking at it, we will get a number from these numbers. That is, the total number of outcomes of the experiment is 7. Here, getting an even number is an event. Since the even number can be 12, 14 or 16, we can say that the number of favorable outcomes for the event are 3. Probability of an event is equal to the number of favorable outcomes for that event divided by the total number of outcomes of the experiment. Therefore, the probability of getting an even number on the slip drawn will be 3 by 7. Next example, Harsh bought 10 lottery tickets. If a total of 4,500 tickets were sold in the lottery, what would be the probability of winning the lottery by Harsh? The total number of lottery tickets are 4,500. The probability of selection of each lottery ticket is equal. We can say that the total number of outcomes of the experiment are 4,500. Of these, Harsh has bought 10 tickets. In this way, Harsh can win the lottery if one of the 10 tickets will be selected. In this way, there are 10 favorable outcomes for the event of winning the lottery by Harsh. We know that the probability of an event is equal to the number of favorable outcomes for that event divided by the total number of outcomes of the experiment. So here, the probability of winning the lottery by Harsh will be 10 divided by 4,500 is equal to 1 divided by 450. Next example. Suppose you have 3 coins. What will be the probability of getting heads on the 2 coins and tails on the 1 coin if all 3 coins are tossed together? When we toss 3 coins together, the outcomes are as follows. The total number of outcomes of the experiment when tossing 3 coins together is 8. We have to find the probability of getting heads on the 2 coins and a tail on 1 coin. Can you tell me what are the favorable outcomes in this situation? Think. Absolutely right. There are 3 situations when we will get 2 heads and 1 tail. That is, the number of favorable outcomes in this experiment is 3. Since the probability of an event is equal to number of favorable outcomes divided by total number of outcomes of the experiment, therefore, the probability of getting heads on the 2 coins and tail on the 1 coin is 3 by 8. So today we have seen some interesting examples related to chance and probability. In the next video, we will see some common mistakes related to them. Today we will see some common mistakes related to chance and probability. Mistake 1. Believe that the number of favorable outcomes of an event is the probability. Some children believe that the number of favorable outcomes of an event is the probability of that event. For example, if children are asked, if 2 coins are tossed at the same time, what is the probability of getting heads on the both coins? Some children think that the outcomes are HH, HT, TH or TT, in which favorable outcome HH is only 1. Therefore, children say that the probability of getting heads on both coins is 1. This is a misunderstanding. The correct understanding is that the total number of outcomes of the experiment for the event of tossing 2 coins is 4 and the number of favorable outcomes for the event of obtaining heads on both coins is 1. So, the probability of getting a head on both coins is 1 out of 4, that is 1 by 4. Mistake 2. Understanding that the probability could be greater than 1. Some children think that the probability of an event can be greater than 1. But this is a misunderstanding. The probability of an event can be 0 or greater than it or 1 or less than it. Mistake 3. Outcome of a random experiment can be controlled. Some children make the assumption that they can achieve the desired outcome in the random experiment. For example, they think that if they keep head on top and toss the coin, they can get the desired outcome. Similarly, they think if a dice is thrown with a specific force, the desired number can be obtained. Remember, in the context of fair dice, the result cannot be controlled. So, the outcome cannot be predicted precisely. Also remember that if the dice is not fair, then the desired outcome can be obtained. But in such case, we cannot call the experiment a random experiment. Mistake 4. Treating all outcomes as equally likely outcomes. If we tell children that there are 15 slips in a box in which number 1 is written on 10 slips and number 2 is written on 5 slips, if one slip is drawn from all the slips at random, whether the possible outcomes are equally likely? Children think that the number written on the slips is either 1 or 2. Hence, the outcome will be one of these number. Therefore, they think that the probability of getting each number is equal, that is, the result is equally likely. But this is a misunderstanding. Here, number 1 is written on 10 slips and number 2 is written on 5 slips. So, the probability of getting 1 is greater than the probability of getting 2. Therefore, the possible results in this situation may not be equally likely. Mistake 5. Lack of understanding of equally likely outcomes. Some children think that it is difficult to get 6 by throwing the dice, while it is easier to get a number smaller than 6, such as 2. This is a misunderstanding. The probability of getting 1, 2, 3, 4, 5 or 6 of these points on throwing the fair dice is equal. So, the probability of getting 6 is as much as the probability of getting 2. So today we have seen some common mistakes related to chance and probability.